In today's video, we're going to pick up where we left off last time. We are on the third page of the 2-2 to 2-4 notes. And we are right here. We're going to look at what's in this box. So let's zoom in on that. And what we're talking about here is we're still talking about deductive reasoning. All right, with deductive reasoning, we can prove that a conjecture is true. And one of the ways to do this is with laws of logic. And the law of logic that we're looking at this point right here, it's right here. It's called the law of syllogism. And the first thing it says is that this law is similar to the transitive property of equality. Well, we're going to talk about the transitive property of equality in the next section, which is section 2-5. So let me write you a little note about the transitive property of equality, and then we'll kind of compare that to the law of syllogism. So down here, in this box on the left here, you have an example of the transitive property of equality. But what I did for you right here is I wrote it in a more general form. And what it just says that if A is equal to B and B is equal to C, then A has to equal C. That should make sense that if two things, A and C, if they're both equal to the same thing, B, then they have to equal each other. So that's really what the transitive property is. And then I'm going to go on the side over here and I'm going to show you the structure for the law of syllogism. So let me get off to the side here. So what we're going to do is we're going to use this law of syllogism to prove that an argument is valid. And it has the structure that I just wrote down for you right here. All right, now, what I want you to notice is that there's 3 if-then statements. Remember, this means this arrow right here. This means if P, then Q. So what you see here is you see 1, 2, 3 if-then statements. So they're all conditional statements. And I drew this line here because this third statement is going to be your conclusion. And so to use the law of syllogism to prove by deductive reasoning that you have a valid argument, it has to fit this structure. So the structure that you're going to try to notice here is, first of all, again, I said you have 3 if-then statements. But did you notice that how the conclusion of the first statement is the same thing as the hypothesis of the second statement? So these have to match. And then the conclusion then will be the hypothesis from the first statement, that's P, and the conclusion from the second statement, that's R. So as long as the argument fits that structure, you're going to conclude that it's valid. All right. I've highlighted the structure for you with some colors because I think that's another nice way to do it. So what you see here then is, again, these two have to match. So the then part of the first statement has to match the if part of the second statement. And then the conclusion on the third line down here, again, will be the if part from the first statement and the then part from the second statement. So this is the structure that we're looking for right here. If we see that, it's valid. If we see any other kind of structure other than that right there, it's not valid. All right, and we're looking for something that's valid by the law of syllogism. So I'm going to use these colors to highlight the examples, and I think that'll probably work best. Probably easiest to see the structure that way. If you want to write this down in the margin of your note packet, that's fine. But otherwise, let's move on to the examples, and I think you'll see the structure still. So let's look at the example they have in the box right here for the law of syllogism. And I'm going to go ahead and highlight this for you. Here is our example of the law of syllogism. And you should see that it does fit that pattern that we're looking for, so it is valid. So up here, the given where I'm drawing right here, you have two if-then statements, and then your conjecture is your third statement. And I think you can see that things are matching up like they should be. The important part to look for again is the conclusion here in green of the first statement matches with the hypothesis of the second statement. And then your conjecture is the hypothesis from the first statement, and then the conclusion, the blue part, from the second statement. So if I read it real quick, it says, if you have a horse, then you have to feed it. The second statement is, if you feed a horse, then you have to get up early every morning. And then the final conditional statement, the conjecture is, if you have a horse, then you have to get up early every morning. And so that is valid by the law of syllogism. Let's take a look at example 5, numbers 6, 7, and 8. I'm going to go ahead and highlight number 6 for you. Number 6 does fit the structure we're looking for. If I said it with P's and Q's, it would say, if P, then Q. The second statement would be, if Q, then R. And the conjecture would be, if P, then R. Or if you want to do it with the colors, it would be, if red, then green. Second statement would be, if green, then blue. The third statement, the conjecture, would be, if red, then blue. I'll read it with the actual words. It says, if you buy a car, then you can drive to school. And then it says, if you can drive to school, then you will not ride the bus. The conjecture is, if you buy a car, then you will not ride the bus. So this one is valid by the law of syllogism. So number 6 is valid by the law of syllogism. So we just write valid. If it doesn't fit the correct structure, as soon as we see that, we know it's not valid, or you could write invalid. Let's move on to number 7. I'm going to highlight that one for you. Number 7, after I highlight it, it does fit the correct structure. If I read the first statement, it's if red, then green. The second statement is if green, then blue. And then the conjecture, the third statement is if red, then blue. So again, that is the correct structure. So this one is also valid by law of syllogism. If you want me to read it to you, it says if K is obtuse and it does not have a measure of 90 degrees. The second statement says if an angle does not have a measure of 90 degrees, then it is not a right angle. The conclusion then, or the conjecture I should say, is if angle K is obtuse, then it is not a right angle. And that is a valid argument by the law of syllogism. So for number 7, we write that it is valid. And let's take a look at number 8. So I'm going to highlight this one for you. I'm going to stop highlighting right there because you can see already that the structure is not correct. The first statement says if red, then green. So it says if two segments are congruent, they have the same measure. The second statement starts out right here with two segments that have the same measure, but then the conclusion of the second statement is the same as the hypothesis of the first statement. And that is not the correct structure. So if you're looking at how I highlighted the other ones, this one right here, that should have been blue. All right? That should have not been the same as the if part of the first statement. Again, looking at this structure, it looked good so far. This was red, this was green. Two segments that have the same measure. This was green. That part still looks good up to there because we got two segments that have the same measure. But then this is the problem right here. And I put the note here that that should be blue. Now, I don't even need to go and consider any further. All right, I'm not even looking at this conjecture down here because as soon as I see that the structure fails or is incorrect, I know that this argument is not valid by the law of syllogism. Okay, so it's invalid. Number 8 is not valid. And let's go on to 9 and 10. I've gone and highlighted number 9 for you. And what we have to do is we have to draw a conclusion. So really, we just have to complete that structure of the law of syllogism. Now, if you read this, you can see that the if and the thens are kind of missing on here, but I'm going to read it with them so you can see or at least hear what the structure is. So the first statement here is right here. It says, if you are sailing, then you are relaxed. The second statement is, if you are relaxed, then your blood pressure is relatively low. So you can see that those first two statements fit like they should, right? You have the then part of the first statement. That is the if part of the second statement. That's the correct structure. And then you can see this next statement. They start this next statement with, Becky is sailing. So again, that's the same as the red one right here. That's the same as the hypothesis of the first statement. So then all we really are missing then is we just need to fill in the blue part. And then we would be done. So our conclusion is really the conclusion from the second statement. And that is that Becky's blood pressure is relatively low. Now let's go on to number 10. I've gone ahead and highlighted number 10. And you look at the structure that we have here so far, it looks good, right? We're going to try to get a valid conclusion here. So just looking at the structure, the first statement, the first conditional is, it says, if red, then green. The second conditional says, if green, then blue. And so then the third statement, the conclusion should be if red, then blue. So all we have to do is write in the blue part. I've written in the valid conclusion for you. And you can see the structure here is correct. This one, I'll just go ahead and read it off to you. So the first conditional statement says, if two segments intersect, then they are not parallel. The second one says, if two segments are not parallel, then they could be perpendicular. And then you can see they started the third statement, which would be the conclusion. They started with this part right here, which matches the hypothesis of the first statement. Two segments intersect, and it tells you that these two segments, segment EF and segment MM, they intersect. Well, then all you have to do is, to finish the conclusion, is just add on this blue part here that they could be perpendicular. So there you go. You've got these two segments, segment EF and segment MN. They could be perpendicular. And that's it. That was a relatively short one today. I think that was, we put in a lot of work on the last video. And, we understood a lot of the background information that we needed for the rest of this section. So this was a short one. Thanks for watching, and I'll see you guys in school soon. Thanks. Bye.